Right, in this little video we're going to try to explain the idea of calorimetry. Calorimetry is how we can calculate the change in enthalpy. So the change in enthalpy is going to be equal to the energy that is causing the mass of a substance times its specific heat capacity times its change in temperature. So we're going to find the enthalpy of this reaction because it's the same amount of energy as has caused a change in the calorimeter. So in this question, it says a burning candle heats 100 grams of water, which is 100 milliliters, from 16.4 degrees Celsius to 25.2 degrees Celsius. Yes, key to this is knowing that 1 milliliter of water equals 1 gram and that 1 liter of water equals 1 kilogram. That'll help us with these sorts of questions in the future. So my mass of water is 100 grams. My specific heat capacity of water, because that's the chemical that's being heated, is 4.19 joules per gram degree Celsius. You'll see this number all sorts of times. It's also in your data booklet along with aluminum and iron and a few other chemicals. And then delta T is the change in temperature. Now the water that's being heated by the candle goes from 16.4 degrees Celsius to 25.2 degrees Celsius. So it's going to be T initial minus T final. So you get 16.4 degrees Celsius minus 25.2 degrees Celsius, which if you crunch the numbers is negative 8.8 degrees Celsius. This is going to be measured in some sort of system where they've got 100 milliliters of water that is being heated by a candle that is burning. And so the heat is being transferred into the water, which is then changing temperature. So now Q, or delta H, equals Q equals MC delta T. I'm going to substitute into MC delta T. My mass of water is 100 grams. My specific heat capacity is 4.19 joules per gram degree Celsius. And my delta T is negative 8.8 degrees Celsius. Put this into my number cruncher, and I find out that I have negative 3,687.2 joules. That's what my calculator is going to tell me, obviously not the joules. Those are all the numbers. If I look back here, though, I've got 3 significant digits all over the place. So this should probably only be 3 significant digits. Between you and me, a joule isn't a lot of energy. So this is going to be negative 3.69 kilojoules. And that's the amount of energy that the candle gave off to heat the water. Water has a pretty high specific heat capacity, which means that it takes quite a bit of energy to change its temperature. Things like aluminum have a much lower specific heat capacity. Air has a low specific heat capacity because a small amount of energy changes its temperature a lot. We'll continue on from there, but this relationship is really important. And anytime that you're doing MC delta T, that's going to give you the energy of something that's caused a change. Maybe it's a change in state, maybe it's a change in the bonds in intermolecular forces, but this is allowing us to measure the change in enthalpy, and we'll always be talking about that when we're talking about enthalpy throughout the whole unit.